In this unit, we're going to be spending a lot of time with fractions, decimals, and percents. So for this first video, let's take a look at some ratios and rates that have fractions in them. So our first example is a train is traveling at a constant speed, which means it's going the same speed throughout its journey, at 7.5 miles in 6 minutes. At that rate, how far does the train go in 1 minute? Now when it's asking us how far it goes in 1 minute, it's asking us to find its unit rate. Remember, a unit rate is a rate per one. How fast does it go in just one single minute? So for this first example, I'm going to use a table to kind of organize my information. And then for the examples after this, we'll move away from our table. So it tells us in our problem that the train goes 6 minutes or travels for 6 minutes and goes 7.5 miles. Our job though is to figure out how many miles it goes in just 1 minute. Okay. So how are we going to figure out what this number is next to this 1? Well, I'm going to start by figuring out what I can multiply that 1 by to make this number here. Now to do that, I need to divide my miles divided by my minutes. We've been practicing this a lot the last few units. So I'm going to start with my second quantity, miles, and divide it by my first, minutes. Okay, so I'm going to do 7.5 divided by 6. So let me rewrite that problem over here. Now we have to use our knowledge of dividing fractions to help us solve this problem. So first thing I'm going to do is I'm going to make this into an improper fraction. Remember, to divide fractions, you need two fractions. So we multiply our denominator times our whole number. 7 times 2 is 14. Add the top number, 15. Denominator stays the same. Over here, I need to make this 6 into a fraction, so I'm going to place a 1 underneath it. And now I'm all set to do my division. So what I'm going to do next is reciprocal. Remember, we do the reciprocal of the second fraction. So instead of 6 over 1, I'm going to write 1 over 6. And the minute I do that reciprocal, my problem becomes multiplication. All right, let's multiply straight across. 15 times 1 is 15. 2 times 6 is 12. And now I still have an improper fraction for my answer. So I'm going to convert this back into a mixed number. So how many 12s go into 15? Well, that would be 1. Let's see, 112. That means I'm 3 away from 15 still. So 1 and 3 12ths, which we can also simplify a little bit further because there is a common factor for 3 and 12. So we can divide each one by 3. And so we get this answer, a final answer of 1 and 1/4. So this train is traveling 1 and 1/4 miles per minute. So what are some key takeaways here? Well, when we determine how far the train went in 1 minute, this was an example of finding a unit rate. Remember, when we do a unit rate, it's the same as finding the constant of proportionality, okay, because these ratios are equivalent. To find a unit rate, or constant of proportionality, we use division. We're going to set up a division problem. We divide one quantity in our ratio by the other. Now, the quantity we're finding one of is always going to be the second quantity in our ratio. So since we were trying to find 1 minute in our problem here, we're going to make sure that our number that represents minutes is the second number in our division problem. So let's practice this. A machine packs boxes at a constant rate of 2/3 of a box every 1/2 minute. What is the number of boxes per minute that the machine packs? So here's our question. Are we asked to find how many boxes are packed in 1 minute or how long it will take to pack one box? So up here in our problem, when it says per minute, that's our giveaway. We want to figure out how many boxes we can pack in 1 minute. So when I set up my problem here, and I'm going to try to find this unit rate, I know I'm going to use division, but I want to make sure what I'm finding one of is our second quantity in our division problem. So since it says per minute, I'm going to put minutes second. That means boxes will come first. Now this is a nice problem because it's already set up for us because we both have two fractions here. So I'm going to go right to making a reciprocal. So this becomes 2 over 1 and my division becomes multiplication. First fraction stays the same. 2 times 2 is 4. 3 times 1 is 3. This is improper. So I'm going to say, all right, well, how many 3's go into 4? That would be 1. I'd have 1 left over and my denominator stays the same. So I could pack 1 and 1/3 boxes every 1 minute or per minute. Okay, let's try one more here. A train travels 2/3 of the distance between two cities in 2/5 of an hour. At this rate, how many hours will it take to travel the entire distance? Okay, so let's think about this. Are we being asked to find how long it will take the train to travel one whole trip or how far the train will travel in 1 hour? Entire distance. Well, that would be the whole trip. So what we want to find one of, what we want to find our unit rate for is one trip. So I'm going to make sure that distance comes second in my problem. Remember, what we're finding one of goes second in your division problem. That means 2/5 an hour is going to go first. I got another fraction divided by fraction, so I'm going to go right to my reciprocal. So 3/2 times 2/5 will stay the same. 2 times 3 is 6. 5 times 2 is 10. This can be simplified because 6 and 10 share a common factor. You can both multiply 2 to make 6, 2 times 3 and 2 times 5. So I'm going to divide each one by 2. And so for my final answer, I get 3/5, which tells us that it would take 3/5 of an hour to travel that entire distance. So to summarize, to find a unit rate, to find a rate per one, we use division. And what we're finding one of is going to go second in our division problem.